welcome back. All right, so we are looking at 1.2 today. Once again, this is going to be split into two videos. So make sure you watch both of them. You can split these two videos over Thursday and Friday to take and get your work done so it's not quite so much all at once. Let's go ahead and jump right in. So what we are looking at here is we're solving for x. So we just want to solve for the variable. Obviously, most of these are fairly complex and have a lot of steps. The first one's just a simple two-step equation. The rest of them, obviously, a lot more complicated. We've got square roots and cubed roots. We've got exponential equations. So I'm going to do a couple of them with you so that way you have an idea of what you're doing, okay? All right, the first one we're going to look at is number 4. So let me just make this big. All right, so for number 4, we have the square root of x squared plus x minus 2 equals 2. Now, we can't do anything with what's underneath the square root until we get rid of the square root. So if you remember from last lesson, how do we take and get rid of the square root? Well, we're going to square it on both sides. So this squared cancels out the root, so we're just left with x squared plus x minus 2 equals 2 squared is 4. Now, when we square a root or cube a root or fourth a root, whatever we need to take and do to get rid of the root, it changes nothing underneath the root. So it changes nothing underneath here. So when we squared all of this, we didn't square the x squared, the x, and the negative 2. We just squared the whole thing, which canceled out the square root symbol. So it'll never change what's underneath your square root symbol. All right, so now we need to get everything to one side because the only way to solve a quadratic is by getting it set equal to 0. So we're going to subtract 4. So we end up with x squared plus x minus 6 equals 0. So now what we need to do is figure out, okay, what two numbers multiply to give us negative 6 and add to give us positive 1. So if we think about the different things that multiply to give us 6, 1 and 6, 2 and 3, that's it. If we have a positive 3 and a negative 2, is that going to give us a negative 6? Yes. And is that going to give us a positive 1 if we add them? Yeah, it sure is. So we're going to write out our factored form of this. So x plus 3, x minus 2 equals 0. Now, we set each of these equal to 0, so x plus 3 equals 0, and x minus 2 equals 0. And then we just solve for x. So we subtract the 3, we end up with x equals negative 3. We add the 2, so we end up with x equals 2. So our two solutions to this problem are x equals 2 and x equals negative 3. So anytime we have a squared in our function, we're going to end up with more than one solution. So just like we have here, we have negative 3 and we have 2. We have two solutions for this. All right, the next one we're going to take a look at is number 8. So we have 5 to the power of x equals 1 over 125. Now you may be wondering how, by taking 5 to any power, are we going to get a fraction? Well, when we take any number to a negative exponent, it's going to give us a fraction. So 5 to the second power would be 25. If we did 5 to the negative second power, it'd be 1 over 25. Here we're looking for 125. So 5 to the third power is 125. So because we need 1 over 125, it's just x equals negative 3. So with the problems like those, I think it's 7, 8, and 9, you're looking to figure out, okay, to what power do I have to take this base number to get my other number? So test it out. If it's a fraction, make your x value a negative. If it's a whole number, then it just stays positive. Alrighty? Excellent. Okay, the next thing we're looking at is more with our inverse functions. So your keyword for today is function. Function. So let's see. Number 10, students were given a set of data to graph. After they had completed their graphs, each student shared his graph with his shoulder partner. When Ethan and Emma saw each other's graphs, they exclaimed together, "Your graph is wrong." Neither graph is wrong. Explain what Ethan and Emma have done with their data. So we've got Ethan's graph over here, which looks like so, and then we've got Emma's over here. If neither graph is wrong, what do you suppose they did to have two different looking graphs? Think about how we graph things first and foremost. So notice this point here is just barely above the x-axis, just a little ways off the y-axis. This point's kind of in the same spot if we were to turn this a little bit. So they're both in a curve. So what they actually did is they switched the domain and range. So what they did is switched domain, which is your x values, and range. I'll show you this in just a second. So they switched the domain and the range. So they switched their x and y values. That's how they have their graph looking two different ways. Instead of graphing x first and then y, what they did is one of them graphed y first and then x, the other one graphed x and y. So neither one is technically wrong. It's just they switched around their domain and range when they graphed it. That's not necessarily a wrong thing to do. We're used to, we graph it x then y, but in this case, because they were dealing with a real life situation, they got it flipped around. All right, for number 11, it asks, let's shrink this down, and then scroll. Number 11, describe a sequence of transformations that would take Ethan's graph onto Emma's. So we want to take and get Ethan's graph, which is curving like this, to curve like Emma's does. So what do you think we could do? There's a couple different ways. So one thing is we can't just rotate it and we can't just flip it. That's not going to get it to the right location. It kind of keyword there is saying that there's a sequence of transformations. But what we can do is if we reflected these points over the x-axis, then they'd be down here extending out, and then we could rotate it up 90 degrees. So reflect, let me make this larger so you can see what I'm writing. Reflect over x-axis, then rotate 90 degrees. Let's see, we're going this way, so counterclockwise. So this is one possibility for how we can take and use a sequence of transformations to get Ethan's data to where Emma's data is. Now, another way that we can take and do this, which involves only one transformation instead of two, is, this is one, to reflect over the line y equals x. So reflecting over the line y equals x, which is the diagonal line with a slope of 1 that goes through the origin, will actually reflect these onto each other, and then they'll be the exact same. So two different possibilities for how we can do this. Either one is perfectly acceptable. All right, so your keyword for this lesson is function. Function. For today, make sure you get 1 through 12 done. So 12 is looking at a graph and there's a story, and you're just going to answer the questions about it. That you're basing them off of the graph that's given there for you. So make sure you take a look at that. And then tomorrow's part 2 will look at 13 through 27. So if you have any questions, feel free to ask. Have a great day.